Good afternoon to everybody. I'm Chiara Piccini. It's a pleasure to welcome all of you to this transnational training course. Just to share some background. Okay. So the central topic of this course is the investigation of the neural processes, the learning problems, and the impact of digital technology on children's development. The course is the first of our transnational courses planned by the Ready Project. Ready Project, as you can have also the chance to see on the website, is aimed to address disparities in reading and writing acquisition through personalizing technology and also by taking into account the cognitive and the societal factors, risk and protective factors in reading and writing acquisition. The project has a large partnership. We are 9 partners from 4 different countries. And we have 3 main objectives. The first one is to enhance primary teacher skills on the societal and cognitive underpinnings of literacy acquisition, with a special focus on disadvantage in literacy acquisition. Then to identify children at risk for learning and school difficulties in acquiring reading and writing, and finally to implement a digital platform to empower the cognitive and psychological underpinnings of reading and writing across different countries and circumstances. Thus, these 3 objectives have 3 main deliverables that are the teaching training package, an interactive evaluation platform for primary children, and a game-based intervention toolkit. So far, we are in the heart of the teaching training package. Most of our partners already started the national training courses, and now we have the pleasure and the happiness to have the first international training course that will be done also in the following years. The project last 3 years. It started at October 24 and it will end at October 27. But we hope that the deliverables and the actions of the project can have an impact also later on. So I leave in a few minutes, I leave the floor to Pablo Delgado, but first of all, just a shared look to the program, as you already saw, probably from the brochure. We have a very full and rich plan for today, with 2 invited speakers, Paavo Leppänen and Susanna Otiano-Leppänen. And the organization of the course sees both teaching sessions, but also some phases for discussions, for general discussion, but also for discussion within each country. So after a teaching session, we will have the chance to get into a specific room for each country so that also in our own language we can speak and discuss on how some topics that we heard can apply in our own country. Okay, so thank you again for coming, and Pablo, the floor is yours.
Okay, thank you very much, Chiara. And thank you for all the participants. We are really happy that you are here with us. So welcome, as Chiara said, welcome to today's international training course of the READY project. And yeah, we are really happy also to have you here for an exciting lineup of talks that will deepen our understanding of the complex dynamics in education, particularly around supporting students with learning challenges. These sessions will, I think, they will offer both theoretical insights and, most important, practical approaches to help enhance our teaching practices. As Chiara said, we are fortunate to have two distinguished speakers with us today, both of whom are leaders in the fields of educational psychology and cognitive neuroscience. Our first speaker is Professor, I'm sorry for the pronunciation, Paavo Lepanen. I don't know if it's correct. A professor of psychology at the University of this name is more complicated, Jyväskylä, Finland, in Finland, and director of the Center of Excellence for Learning Dynamics and Intervention Research. Dr. Lepanen's extensive research focuses on understanding why some children face learning difficulties while others, despite similar risk factors, succeed. In this talk, he will explore the current perspective on learning difficulties as multidimensional and multifactorial disorders, shedding light on the relationship between learning problems and later psychological difficulties. And he will discuss the key factors influencing this relationship and how they shape both cognitive development and emotional well-being, and particularly in children with neurodevelopmental disorders. And after Paavo, we have Dr. Carol Susana Otieno Lepanen, who is a leading researcher in cognitive neuroscience and digital inclusion. She's currently the principal investigator for the Erasmus Plus CBHE project, Digital Transformation for Neurodiversity Inclusion in Africa and Asia. And this project is focused on inclusive digital transformation for neurodivergent individuals across Africa and Asia. Her research delves into the impact of emerging technologies on learning, with a special emphasis on neurodiversity also. And as I said, digital inclusion. In her talk, she will discuss the implications of excessive screen time, online interactions, and use of social media, and particularly in the context of, again, neurodivergent learners. She will explore how these factors affect cognitive function, socio-emotional development, academic outcomes, and so. Well, also discussing potential strategies for using digital tools to enhance learning. And yeah, as Chiara already said, we will have like a 30-minute discussion session after each talk, where we encourage you to reflect on the insights shared, to ask questions and discuss how these insights can be applied in your teaching practices. And yeah, that's all. Now, well, I would like to thank Pablo and Susana for being here. I'm eager to know. So the floor is now for Pablo. Thank you.
Thank you very much for these kind words and for the introduction. I hope you are seeing my slides soon in the presentation mode. Okay, do you see them?
Yes, perfect.
Okay, and okay, let's see. Okay, so I will talk today or give a lecture on learning difficulties. There are multiple risk factors and associations to mental well-being. And thank you for Chiara and colleagues in Firenze for inviting me. I'm always excited to talk about these topics, which has been close to my heart since I started my doctoral studies. What I want to do today is to talk about kind of in three parts. First of all, to think about what are the learning difficulties and some, and I go through the main ones like language, reading, math, and attention, just a little skim from each one of them so that we understand and then view them from the multi-dimensional and multifactorial perspective. And I want to, because this is about the neural factors as well, so I briefly touch on that area as well. And secondly, I will talk also about learning difficulties and how they are associated to mental well-being, both in school age and maybe to the later adulthood mental well-being. And this part may have more implications then for the classrooms as well and for teachers, which I hope that you can discuss in these breakout rooms. And my last part will be giving some concluding thoughts and briefly introduce at the same time our kind of approach we are taking in Interlearn Center of Excellence. And just to note that these parts are not following exactly the timing for the breakout rooms. So Chiara, you have to also follow a little bit because we are a little bit late from the time that I was estimating for that. But we'll see how it goes. And I think the questions we will reserve to the end. So maybe it is better that way. Okay, let's then keep rolling here. So what we all know from our own experience, whatever our profession or field is, that learning and learning problems and well-being and mental health for that matter, it takes place in a very complex setting of environment, including our family, also school and friends, and more recently, digital environment has become an important environment. And as we see in the picture, there's a phone that has become almost as an extension of us and even like a close friend. But Susanna will talk more about that aspect. And then we have, of course, the individual factors, cognition, and attention is, of course, part of cognition. For example, how we can regulate ourselves, how motivated we are, what are our emotions related to learning as well. And that will, of course, result in our behavior. And all of this depends on a combination of environment and genes, so the heritability, and how that affects our neural development. So I try to touch a little bit on these areas during my talk. First of all, this has been a kind of motivator for me to look at learning and learning-related emotional difficulties. They indeed form a wicked societal problem at the moment. And this is true all over the world, in Nordic countries, in Europe, as well as in the Africa and Asia, as we have learned now during our experience. So it's estimated that about 10 to 15% of all children suffer from one or more developmental disorder. And I'll go through briefly those more, such as reading, math, or attentional, or also psychological mental problems. And I just took some Google search. In Italy, the child population between 0 to 14 years is about 12%. That means that there are about 7.1 million children in Italy at that age. If you take a little bit older range, then this will be more than almost 9 million. Now, what this means then, just purely from the statistical point of view, is that about 1 to 1.4 million children in Italy suffer from various learning problems or neurodevelopmental disorders. Now, what are the most common developmental learning difficulties? These might be familiar to most of you, but I guess I'll just go through them quickly here. So what is common to all of these learning difficulties is that these disorders or difficulties, I prefer term difficulty myself because it's not so labeling. It's not dependent on a physical illness or, for example, brain injury due to some head trauma or accident. And they are not usually caused by any one single causal or risk factor, rather a consequence of complex interaction with genetic, neurobiological, and environmental effects, as we shall see also later. So what are they? So I will briefly talk about the 4 of them: developmental language disorder, reading difficulties or dyslexia, mathematical learning problems or dyscalculia, and then attentional difficulties as a clinical diagnosis known also as attention deficit hyperactive disorder, ADHD, but it also involves a part where only attention is a problem and not so much the hyperactivity. Then we have, of course, other issues also like autism. We have conduct disorders that's more psychological, and there's also motor and coordination disorders and visual spatial perception disorders. But I will not talk too much about them today, rather these 4 a little bit. So now, as a background, I want to share a few thoughts about what could be like a general or general to several difficulties or disorders, or what could be specific for these disorders as risk factors. So these are rather questions that I would like us to think about during my presentation, and maybe you can discuss them later on or just keep it in mind. So are learning difficulties, different ones, just a low end of typical performance? Does it mean that they are only poor skills that involve a less efficient machinery? We don't think that anyone who have learning difficulties that they would be due to laziness, for example. So it should be something that relates to the skill level. Or do we think that learning difficulties involve somehow different type of brain development, so atypical organization of some of the brain processes starting from early development onwards? So this would lead to, for example, atypical developmental trajectories or paths. And to what extent these different learning difficulties share similar or general neurobiological risk factors. If you think, for example, attention or motivation or socio-emotional factors. And then second, we think that to what extent are these neurobiological risk factors specific to different or overlapping, as we think of co-occurring learning difficulties. So then we talk about comorbidity. For instance, is it so that speech perception problems that we know that are related to the reading difficulties, are they mainly related only to reading difficulties, and perhaps language problems, but not the other learning difficulties. What we know already very well is that there is a genetic variation in the background, and this leads to hypothesis that there must be also then variation in brain functions. But then we ask that, is it so that the environment modifies only these general risk factors that are shared between different difficulties, or is it so that the environment affects also these learning difficulty specific factors? So we can, here's such a schematic picture borrowing from my colleague. You could think of like different neurodevelopmental disorders, dyslexia, dyscalculia, ADHD, and so on, and think that in terms of the brain functions, there could be in different parts of the brain certain atypicalities or maybe slight abnormalities, and they could serve as risk factors. And so are these common or separate, or these different disorders? Okay, let me now briefly go through each one of them, just the main key features. And first of all, we go through developmental language disorder. And this is especially, I got good slides from my colleague Leena Ervast, who specialized speech and language therapist in Tampere University Hospital. We have been collaborating also quite a long time. So what is language developmental disorder? This was previously known as specific language impairment, but scientific community decided to rename this and maybe related to some of the characteristics. So it's a neurodevelopmental condition that emerges in early childhood and also is seen and to persist until adulthood. And there is a great difficulties in learning, especially understanding and using spoken language properly. And it can affect your speaking or comprehension of spoken language, and also in various degrees of severity in different aspects of language. For example, having proper vocabulary, so the lexical knowledge, or syntactic or pragmatic skills of language. And it can lead to long-lasting learning problems, and it's estimated to be 5 times higher than in children who have developed typically without language problems. But it's also highly heterogeneous condition. That is important to remember. They are not all alike. And if you think of these, then it's about 20% of children who actually experience so-called language delays. So they start speaking later than typically is the case. So we call them late talkers. However, they often catch up and don't have any bigger problems. We found in our longitudinal study, which I'll talk about later a little bit more, that if you came from the at-risk family, had a familiar risk for dyslexia, then your late talking affected also your reading skills at school age. But otherwise, they caught up other children. And about 7% of preschool age children, and the percentage varies, the range depending on the determination and diagnostic criteria, suffer from these problems. Now, what are the kind of main characteristics? So difficulties in auditory and non-speech processing. So it's the cognitive domain that is important for understanding and speaking language. It has also those kids have often problems also in phonological working memory, and their vocabulary size does not grow in the normal manner. They have problems and recalling and a name of even familiar objects. And mastering grammar is difficult. For example, syntax of the sentences is not correct, and semantics, not understanding the meaning, and also using smaller parts of the sentences like words like morphology is impaired. So they have both problems in speech production and in their also perception and producing also phonology. And then the pragmatic skill problems include using language in social interaction. Now, how is this reflected in school-age children? The learning overall is affected by limited vocabulary. There's also slow and inaccurate learning of new words and concepts. And this slow learning is affecting their also reading and writing skills. And because they have also narrow linguistic working memory, and often they is accompanied with attentional difficulties also, and they have a lower receptive language skills, so understanding and comprehension is affecting both speaking or hearing comprehension and reading comprehension. And that then often leads to lower academic performance. And also difficulties in foreign language learning. By the way, there's a link to the YouTube video here, so I will give as a PDF, then you can look at this video later on. Don't have time now. But if you think of them, so compared to typically developing children, those who have learning language difficulties have 6 times more likely to have reading difficulties. They have also 6 times more likely to have significant spelling problems, and 4 times more likely to struggle with math, which is also significant, and 12 times more actually to have all of these 3 difficulties combined together. If you think of now the risk factors for DLD, the exact causes of different brain differences that lead to DLD are still unknown. There's a complex interaction between genetics and environment that will change the brain development. So we talk about multi-causal background for them. In terms of family history, we know that about 50 to 70% of children who have DLD have at least one family member who has also the disorder or some other neurodevelopmental disorders. And it tends to be more prominent in boys than girls. In some cases, we will see pre or perinatal factors also being accompanied, like being born preterm or having very low birth weight, but this is not automatically leading to language problems. So it's more like a co-occurring phenomenon. And often there is also low level of parental education. So socioeconomic status can also be often lower. The exact causal relationship to development of language disorder, of course, is probably not direct, but it's more like could be that parental also have some issues, and that has been linked into their socioeconomic status. Now let's have a little look then the brain and language in the brain. So language is observed by a very wide network, and this is very schematic picture involving only the key areas for speech and language. And one good thing to remember is that we are sharing, or the language is sharing to a large extent the same network as reading, and it has developed, of course, well before reading ever emerged. So we have the few key areas. Here at the temporal lobe is acoustic phonetic mapping and hearing, importantly. Then a little bit back of it is a sensory motor transformation, so auditory mapping it to the motor representations. And what is classically known here in the frontal part is articulatory-based speech processing. And then we have also here in the further lower part of the temporal lobe is where we have typically lexical processing. But the exact parts are not so important for us now. It's just to give a rough idea. And now just we could give the whole lecture about brain processes and differences, but this is just some quick highlight for you. One example from the Rutgers University, from the Infancy Studies Lab, where I did my postdoc period some time ago. And there we developed a paradigm where we presented infant sound pairs, like this one here, beep, 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 where the second sound was higher in pitch. And you can see that this is brain responses from left frontal and right areas. And you can see that in the red you have the different sound coming, where you have the second part being higher in frequency, that young babies are clearly differentiating it from the often repeated sound that remains the similar tone pair. We don't go into details, it's just enough to us to know that brain is capable of detecting small sound differences, and this is how it looks like if we take the whole head distribution of these brain responses. Now, what is more important is what we see here in the next slide, and that is that the timing of the response from the beginning of the sound differs between those who had some close relative having also language problems, so family history children. And here we have 3 age groups, 6 months, 9 months, and 12 months. And we can see that they all display the similar type of thing. That is that the timing of the response is slower with those who have family history for DLD compared to no family history children. That is shown by these lower bars. And this is true for all age groups here. And what we also see then is that in this graph we see the magnitude of the response, and we can see that in the no family history this response is bigger or stronger in magnitude than in family history, again in all 3 age groups. And then this one picture here on the right finally shows that now the family history here is on this left side and family history on the right side, so no family history on the left side. And you can see that its larger areas also is being activated in those who don't have any family history, also in all age groups. They start to be more similar towards the 12 months. So what we see then we ask, does it have any meaning? Is it related to anything? So this brain responses to this sound magnitude at 6 months is also now associated to expressive language. So that is the produced language at 3 years, and receptive comprehensive language at the age of 4 years. And this can be seen as these scatter plots, the correlation plots between expressive and receptive language and the amplitude or magnitude of this response. And this occurs across both at-risk and non-risk children. Okay, so that was just a very brief that yes, indeed, the language problems have neural basis. Now we are looking at the risk factors for reading. we all know probably very well, because this is the main topic of the ready, that reading difficulties, known also as a dyslexia, they often overlap with other difficulties like math and attention problems. Underlying mechanisms may also partly overlap, and these reading and writing problems are manifested in much slower performance than in peers, and it affects learning in schools, of course. But what is important to notice that it's not due to any lack of intelligence. And we here have a picture of few quite famous people who have had reading difficulties: Galileo Galilei, Albert Einstein, Alexander Graham Bell, Jules Verne, who was a science fiction writer, and Finnish famous architect Alvar Aalto. I'll come back for this issue later in my third part of the talk. So if you think then of reading comprehension and think that it will require some subcomponents or precursor skills. So you have to be fluent in printed word recognition. You must have a good listening comprehension, and also kind of a discourse specific skills. And if you then think, okay, what is the prerequisite for these skills? Then to do the single word recognition, we need phonological coding. And what we also need is so-called orthographic coding, when we can map actually and see the letters and put them together quickly. And then these, on the other hand, presuppose also other lower level precursor skills like phonemic awareness or rapid serial naming is especially important for the fluent reading, like orthographic coding. And listening comprehension requires good phonological memory, oral vocabulary, and syntactic skills. So the language skills play here a big role. So this is just, again, a schematic. And of course, these lower level skills are also often interrelated with each other. Now, I'm not talking too much about reading in like in English or French, because we know that in transparent orthographies like Italian and Finnish, there is a consistent letter speed sound association, and then dyslexia in these languages appear as dysfluency. The consistency or transparency of language means simply that one spells each letter or syllable or word as one pronounces them. And then I can, for example, read Italian. You would understand what I read, but I wouldn't understand myself. So it's a kind of a pseudo words for me. In Finnish, after you have learned 23 grapheme phoneme connections, children can learn any word, or also so-called non or pseudo words. There are no exceptions, there are no irregularities. There's only one bigraph eng sound that is a little bit complex for some children. So therefore, the basic reading skill is acquired by first grade autumn already, and this is the reason for the slow reading and dysfluency as the main feature also. And this can lead then to reading comprehension problems in part. Now, this is just a quick glance for the idea. So here we have the kind of orthographic depth. That means a shallow or transparent, and then there's a deep on the other end, which is irregular languages. And you can see that the most kind of regular or transparent language is Finnish, then comes Greek, Italian, and Spanish, and they have relatively simple syllabic structure. And then we have other languages who have more complex syllabic structure and also are more irregular. Just for your curiosity. Okay, then if you look at the pre-reading skills that are associated with reading difficulties, So we can ask that, do we see already signs well before school whether one later becomes or remains as a slow reader? What we have been doing in Jyväskylä longitudinal study of dyslexia, where I started also my doctoral studies, we have investigated paths to reading and reading difficulties. We have been following two groups of families from birth to school age. At risk about 100 healthy children where at least one parent had dyslexia and a familial background reported by themselves, and we call them a control group without any reading problems. And this just shows the schematics of the whole administration. At the end, we ended up having about 108 at risk and 92 control group children. And you can see here the assessment ages throughout the years. They have been intensively followed up, sometimes 2 times a year, sometimes only once a year, and then from grade 1 to 9th grade. And more lately, we have been studying them also, like all my colleagues, in adulthood at the age of 20, 23, and at the age of 26, we also carried out again some brain studies. We carried brain studies also at 3 other time points earlier. So the domains that we have been investigating here include speech perception, comprehension, and production, various types also, neuropsychological functions like visuospatial skills, articulation, motor skills, and cognitions like memory, associative learning, and of course school achievements, and then child characteristics as well, including attention, physiological reactivity, and temperament. And there was also some intervention studies. I'm not talking about them anymore, and we have been also looking at home environment of these children from that perspective, mainly from the reading perspective, like print exposure, a little bit of parental stress as well. So here are some examples of the preschool and school measures, what have been important in predicting later skills. One of them is letter knowledge. This simply means that children were asked to name as many alphabets as possible. And then phonological awareness, which you're also probably very familiar with, simply means that you are aware of sound structure of spoken language. For example, say car, but drop out R from the end. So what is remained is ka. And then these can be applied to different parts, from the words to syllables and parts of words, and then finally to the single phoneme level. And one other skill that has been important in predicting later skills is so-called rapid automatized naming. It measures simply how quickly individuals can name aloud familiar objects, pictures, colors, or symbols, for example, letters or digits. And this, nobody actually knows fully what is this measuring exactly in terms of cognitive processes, but it measures several processing speed-related skills or processes. And here are just the 2 tables, examples, for example, for the object here on the left. They would be in Finnish autotalo, kalakynä, pallo, talo, auto, kala, and there's some stickiness for those who later on develop dyslexia, even at early age, even at the 3 and 5 years age, that this naming speed is much slower in those children. Okay, next I show you here example of reading development from a 2nd grade to adulthood. This is simply reading speed measured in how many letters these participants read in 1 second. So different texts have been passed out for this particular type of measure. And you can see that there are the green ones here and the red ones. And the green lines tell the speed of those who did not have any family history. And the red lines tell the reading speed development of those with family history of reading difficulties. And you can see that it's not like even those who come from the family history families, many of them just develop their reading speed in the normal pace like the others. But you can see that there is one group here at the lower end that are clearly remain at the lower level throughout until the age of 26 years from the second grade. Now, if you look at then certain trajectories or pathways to the adulthood from the school age, here on the left side we can see several lines. Here the upper two lines represent those whose rapid automatic naming was above and letter knowledge was above 1 standard deviation. And they are here, and you can see that they are better in fluency. And then we have here the black line, and you can see that they also develop from 8 to 9 years, and then to 15 years, and then the adulthood. Everybody develops, and the developmental slope or pace seems to be quite similar. But these who are represent the lowest line here are those who have letter knowledge below 1 standard deviation and who have slow rapid automatic naming. So preschool age, these skills actually tell you how at the group level they will develop in reading fluency. Now, what is interesting is that reading motivation and also affects your reading fluency. And here the upper line represents those who have a motivation higher than 1 standard deviation. And then the two other lines who are who have a lower motivation. So because it's apparent that the more you read, the more motivated you are, and the more you read, so the kind of a cycle of getting practice means a lot for your eventual reading fluency. Now the kind of we look at what were the predictors for adult age reading, and we can see that preschool rapid automatic naming and letter knowledge were most important predictors. And in addition, reading motivation at second and third grades predicts how fast reading fluency develops, but so it predicts the slope of development, but not the adulthood level of reading fluency. It's interesting also that parental dyslexia and how persistent the parental dyslexia has been, that predicts also adult age reading fluency, but it does not predict how fast they are and the slope. Okay, now we've covered the reading, a little bit the cognitive aspects related to it. Now we cover a little bit of the connection between brain activation processes and one's ability to learn to read. Can we see some signs of brain level risk factors already before schools? And now I'm just showing you similar network that I showed for you for language. There are several, we could say, nodes or important parts of the network, and therefore the reading can become vulnerable also at various levels. We don't go them very detailed through, you can later view this, but basically it's the letter word processing area that is important, and then the other areas is the temporal lobe that is shared with language also, that relates to the actually speech perception and acoustic phonetic mapping. And then we have this also the frontal areas that was important for articulation and speech and language, but they also relate to the awareness of the word structure in terms of reading. And then we have so-called frontoparietal attention network that regulates also attention, which is also important also in reading. Now, what we know from the kind of anatomical differences also, people have done this type of white matter tracts, that is where our brain nerve cells are connected to different parts of the area, or the different parts of the brain. We know from the literature and many studies that there are poorer connections between important brain regions that are dealing with the reading network. So this type of structural connectivity, as we call it, and the volume of these white matter tracts, this differs in adult dyslexics. That involves connections between the frontal and posterior parts of the brain, and also the connections from our speech part of the brain to our articulation part of the brain. So they in several different aspects. And the functioning of these tracts is related also to the poor reading skills. But again, this is just a very impressionistic picture that also at the structural level, there are differences on those adults who have reading difficulties compared to ones who don't. But we don't dwell more on this now. Another important brain area is here in the more at the lower part of the temporal lobe, and also back part, in the junction of the back part of the brain. And this is known in the literature as a visual word form area. And this is area that is involved in letter and word recognition. But this area also processes several categories of objects, like here in this picture. And this is a view from the bottom up towards top. This is the left part of the brain. But again, details are not so important here. It's just, again, only one example showing you that when you see words, they are displayed here in the green. And here are good readers, 9-year-olds. You can see that this brain area is activated very well for the words in typical readers, whereas in dyslexic 9-year-olds, this area is not activated at a significant level. But for all other objects, you can see that dyslexic brain also are pretty normally activated. And this suggests that the development of this particular area is important for reading development and can indeed be related to the reading problems. Now, what we have been doing in our own studies, because we started to follow this children with parents who had dyslexia from the birth. Later on, we wanted to study especially auditory processing. Visual processing was not so feasible at that point. And the idea is in why to do like this is that we think that speech perception plays not only role in language, but also in reading, in the sense that basic speech perception is important for forming long-term memory traces. And also these long-term memory traces, on the other hand, affects our speech perception. So there's a reciprocal effect. And this whole thing is important for developing proper phonemic representations. And this in turn is important for being aware of the phonemes, so-called phonological awareness. And this is a ground for then proper grapheme phoneme conversion, as we have learned it. And then, of course, this relates then to the learning decode fluently. Now, what we found basically is that Even this is one of our earliest studies long time ago. We presented this type of pseudo words that we called ata and atta, and they were presented in a sound sequence like this. So it sounded like ata, 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 atta, atta. And this type of difference between ata and atta, or mato and matto, is important in Finnish language because it tells about the phonemic length, and it also differentiates semantically words from each other. And what we found was that if we look here, control group's brain responses and at risk group brain responses, that their brain responses differed already at infancy. Now, of course, more importantly, what we have to ask is this related then anyhow to their later skills? Yes, it is. We found out that this brain response was related also to phonological skills. But here I present only one example of this early brain response at 6 months being related to their skills at 14 years of age, so at the 8th grade. You can see that this correlation takes place only in the at-risk group and not in the control group at all. So the bigger this response was, the faster the children were in reading. And this explains about 40% of their reading speed later on. Now, what is quite remarkable to me is that this infant brain response at 6 months is also associated with reading skills still in adulthood. And this is so-called pseudo-word list reading speed, letters per second, and you can see that it's the same situation. The correlation exists only in the at-risk group and not so much in the controls. And the same is still true for the text reading speed. So infant brain response for phonemic length at 6 months is associated to adulthood reading speed. Okay, now I want to check that what is our situation, because we were a little bit late in, and I think we are late now in time also. Should we having breakout room at this point? And then I continue with the second part. What do you think, Chiara? And
if you can manage in 5 minutes, maybe we can complete the first part. What do you think? Because according to our delay, we have still 5 minutes anyway.
okay, then I go through maybe the math difficulties part, and then I have still something. And because later I want to draw together really what these different things together mean. And I know that in the ready, the math difficulties is not so kind of at the center, but maybe just a quick glance on that will help us to understand also the comorbidities and co-occurrence and maybe the multiple risk factor perspective better. Okay, so this is not from our own study, but our colleagues here in Jyväskylä have conducted so-called first step study from kindergarten to the 9th grade, and they have been trying to look if they try to use these kind of well-known predictors, predict also the reading and math skills. And here is just only the schematic picture, shows you the kindergarten here on the left, later knowledge, phonological awareness, rapid naming related to the reading more. We know that rapid naming actually predicts also math fluency. And then counting, number concept, and visual-spatial relations, these are more related to math. And then they were looking parents' education and family risk for both for reading difficulties and family risk for the math difficulties. And this is simply following them from grade 2 to grade 9. Okay, so what do we see? I just, again, a little bit in an impressionistic style, picking up only a few examples because it would be too much to go through in more detail. So what we can say is that you have noticed probably that I have always in the heading here put the key point of each slide. And that is that several cognitive skills at preschool were associated with math development profiles. And now we can look at the profiles here on the picture on the right. Those who they are so-called early learners, they are already quite good in the first grade and second grade, and they follow to be so until ninth grade, although there is a little bit decline in the curve in their absolute learning. There is not, because this is using here Z scoring, which is a relative measure. And then you have those who have a delayed onset, so they were not so good at the first and second grade, but they seem to catch up later on, the other group. And then we have a group that have persistent math difficulties. So these profiles have been found out by the latent profile analysis, statistical, quite complicated analysis. And then there's a special group that seem to be dropping otherwise like others, but dropping only at the 7th grade. And actually, I'm not going to tell anything about this group because I don't know too much who were these children. Okay, so what do we see then here? So if we look now, we compare these early learners, or the profile 2, we compare them first to the persistent math difficulty profile. And what do we see is that these early learners had higher scores in preschool, now again before school age, in counting and number concepts, in visual spatial relations, and rapid automatic naming. As I mentioned earlier, rapid automatic naming is very predictive also of math problems. But interestingly, they also differ in terms of reading-related skills, like phonological awareness, letter knowledge, word reading, and vocabulary. So there was something that these were also linguistically better, these early learners, in math, although we're talking about the math skills. Interesting, no family risk was involved in these early learners, and the father had a higher education level than these persistent math difficulties. And to be honest, I don't know why this would be. And there was also more teaching of the arithmetic type of playful things at home. Now, if you then compare the delayed onset to this persistent, it's pretty much similar picture. So they differed in counting and number concept, visual spatial relations as well, and ran, but there was no difference in parental factors. Okay, so reading related skills even before school age are important also for math development, and from grade 4 onwards, differences between early learners and delayed onset learners start to diminish. And this one looks some predictors. Just to point out here, if you look only the ones that are here within the red square, so what predicts reading fluency in this particular study is familial risk of reading difficulties, letter knowledge, rapid automatic naming, and then the earlier grade reading. So reading is kind of also accumulatively developing or basing on the earlier skills. And in terms of mathematics, we have here counting skills. So the familial risk is not so much predicting the fluency at the 6th grade in terms of math. There's counting skills, spatial relations, and then the earlier math skills. So in summary, in this study, adolescent reading difficulties can be moderately predicted by family risk and kindergarten cognitive skills in reading, and in math difficulties only by cognitive skills, and the specificity of the models are not very high in any case. But if you add school-age fluency measures, they increase the accuracy of the predictive models. So the better skills they have had in earlier grades, then you are better to predict their skills in the later grades. And although early disfluency is a significant predictor of later disfluency, individual developmental paces still vary, and the prediction, of course, becomes better across time. What about comorbidity? Then this is, to me, quite interesting thing also. And here we have looked at, our colleagues looked at children who have both reading and math problems. And what we see that they follow more or less the developmental trajectory of those who have a single difficulty. So here in the gray dotted line are the typical performers, their profiles from grade 1 to grade 9. They keep on the same track more or less. Again, remembering that this is a Z-scores, which is or the type of measure that is relative to the level of all children. But then we have those who are here with these lines who have reading difficulties. They seem to be poorer earlier, but they seem to catch up. In the math case, they are not catching up so much, but they keep on a lower level consistently. But those then who have both reading problems and math problems, they tend to go down also then in the skills in the same way as if you would have only more severe reading problems going down. So I may have confused here. So this group that in the reading fluency case is performing quite well is math, those who have math difficulties. And in this other case, it's those who have reading difficulties. Sorry about that confusion. So the take-home message is that if you have comorbid problems with math and reading, you tend to do in the same way, even if you had only one single difficulty in terms of these trajectories. Okay, did I spend now 5 minutes? What do you think? Now next will be a little bit of attentional problems.
Yes, thank you. I think it's good if we complete this topic.
What, so should I continue this one too?
How long does it take?
Maybe 5 minutes more.
Okay, yes. With this, you finish the first part, don't you?
More or less. I don't remember exactly what is coming. Okay.
Okay.
So the attentional problems, I don't have so much to say about that. But I guess you all who are teaching in classrooms, you have come across with these children. It's often referred to as attention deficit hyperactivity disorder, but it also occurs without hyperactivity, then also often known as ADD. And these both ADHD and ADD are diagnostic categories, but in real life, they occur in various degrees of severity or difficulty, and they often occur with other learning difficulties as well. And they have children who have attentional problems. They have difficulties in both directing their attention or shifting their attention to a relevant what they should be doing. and they have also problems in sustaining attention. So there are problems in cognitive and action control, but often also problems in emotion regulation. They are often characterized by impulsivity. There's a problem of inhibition of irrelevant information. They are easily distractible. And this is often related to in problems in arousal level. And that's why many children are medicated also with stimulants to keep up their arousal level. They have problems also in vigilance. That means ability to keep focus over a longer time on one thing, important thing. And this, of course, manifests in problems most often also in executive functions. And with executive functions, we mean difficulty to plan, monitor, or evaluate your own actions in task-related or goal-related situations. And attention network involves several sub-processes, like here. Maybe I will just briefly go through them. There is a alerting network is important, includes frontal and parietal cortex, and this is responsible for maintaining a state of alertness and preparing individual to respond meaningfully to the environment. So it helps to maintain attention over time. And then we have this orienting network I have marked with the red circles, certain parts like frontal eye field, and there's a temporal parietal junction important for this part as well, and some other brain areas. And this has a crucial role in directing our attention to specific or meaningful stimuli, as involved in selecting and processing information based on, for example, sensory cues, for example, spatial or non-spatial important elements in the environment. And then we have so-called executive attention, and this is involves our frontal parts here, and also partly our thalamus and their interconnected network action in conscious control of attention and task-relevant information and goal-directed behavior. And this relates especially to concentration and self-regulation. And this relies now very heavily on this prefrontal area, which we call this area. And it has connections, as I later show, all over the brain regions. And what we found in one of our studies is that the inhibition network that is crucial now in these executive functions, this differs from controls in both with attention and reading difficulties. And I don't go into details, but this picture just shows you the significant differences in this medial frontal cortex that is partly related to attention gateway and some other parts here, also both between the groups and differing from the control participants. So summary and conclusions of these cognitive factors. So developmental trajectories for reading and mathematical skills and related difficulties are associated with different, though partly similar cognitive predictors in different longitudinal studies. For reading development, main predictors at preschool age include rapid automatic naming, letter knowledge, but also parental dyslexia, reading motivation, and teaching of letters. And for math, preschool predictors include counting, number concept, also knowing spatial relations, and reading-related phonological awareness, letter knowledge, word reading, and vocabulary, but also family risk for math difficulties, father's higher education, and math teaching at home. And reading and math have reciprocal development influence at early grades, but their developmental bidirectional effects start to diverge then from grade 3 onwards. And they actually also co-occur often in the same children. Okay, then I think that I have a little bit just here left. Just I don't tell about genes at all to you. I just want to say that what is the connection between genes and environment interaction, and it has this type of a spiral of three ways. So genes, we could think that genes determine our developmental path, or we could think that environmental support or the lack of environmental support will determine the limits of our learning. Now there's also what we call evocative gene-environment interaction. So our hereditary aspects or genetic factors will affect to what kind of environments we will end up. So for example, how the environments or our parents react to us, or how teachers react to children. So that depends also on the genetic factors of the child. And here are some examples. For example, temperament is that shy person will avoid other people. That may, in an extreme case, lead to withdrawn child. Or problems in speech perception can result that the person starts to avoid shared book reading events. So how can we think about this? Is that genes create the biological architecture for development, and it develops or creates a kind of machinery, brain and body for learning, but then individual differences in cognition and emotion processes, and it creates also orientation towards environment. But environment plays also very crucial role for the brain development as well. So neither the environment or neither the gene operate in isolation, but they have a complex interaction and they will lead to individual developmental trajectories. So there is not necessarily any miracle treatment that could cure this gene-brain atypicality, but there is a possibility to compensate to go around the gray stone. And this is what we have to think in terms of education, for example. For example, a lot of reading will improve reading speed, although the brain might use different ways to achieve the same reading speed. So it's not like having eyeglasses that can cure our eyesight. Our training and education needs to take more into account the individual skills and come up with the best ways to learn despite these problems. I think that this will end now my first part completely, and we spent a little bit more time here than we intended. Now we have heard about the various learning difficulties and how and their neurobiological and other cognitive factors and a little bit of the emotions, but here tell you a little bit of the Center of Excellence that we are currently running, where we are actually trying to put these things together, what I've been talking about. And this is a consortium of three institutes or two universities, University of Jyväskylä and Department of Psychology, and I'm leading this group, and Department of Education, and that's my colleague Mikko Aro is leading that one, and University of Turku, Department of Psychology and Speech and Language Pathology there, and FinBrain longitudinal study. And here we have actually quite long experience here and extensive research in development, education, brain research, as well as psychiatry in these centers. And you can already saw so many longitudinal studies, different ones that's why we have been able to achieve also this funding for us. And we have been running before two centers of excellence, and we have been concentrating on applied research on this area. And our vision is to identify individual pathways that affect both learning-related mental health, and socio-emotional problems. And we try to understand multiple dimensions and complex effects of risk and protective factors on learning difficulties and their overlap. And Mikko's team especially is interested in developing targeted and integrated personalized interventions. So we try to do this by integrative approach in Interlearn, where we try to achieve integrative understanding of developmental dynamics, neural basis of learning problems, and their interrelations and of different dimensions, and especially related to the psychosocial development and well-being. And we try to do this by mapping risk and protective factors and how they relate to each other. Try to look quite carefully role of environments, family, school, peer, and digital environment. Mainly do this by asking children themselves and families and teachers. And we are also developing a mobile app to actually get also so-called momentary information on daily basis. And then we try to look at factors that affect individual response to educational support. So in terms of intervention studies, the idea is not so much to look whether the classical interventions, whether one or some other is better than the other, but rather look what factors affect that why some children benefit from support and why others don't. And then the idea is also to develop and investigate novel interventions. And this is the kind of schematic illustration of our approach: environmental factors, learning outcomes, and learning-related non-cognitive factors like these socio-emotional issues, and how cognitive skills, self-regulation, and neural factors play a role, and try to put the big picture together. We are working in different thematic areas: developmental trajectories and longitudinal studies on learning and related emotional problems and interventions. And then we have these environmental factors as well, and neural characteristics. And then we have one particular theme related to the methodological solutions and innovations. And this gives you kind of a rough idea of the work package. One has started to look from early infancy, and they are following to 5th or 7th or 9th grade, depending a little bit on the future funding. They've been looking for language development, social skills, emotional development, self-regulation, executive functions. And now we are together doing them from the 9th-year-olds and 5th graders onwards. And then I have been leading mainly the study with starting from the 1st grade to 5th or 6th grade. And we look also quite similar things what they've been already looking in the other FinBrain studies: risk and protective factors, and learning difficulties, and mental well-being. And then the third group of studies relate to the intervention studies: classroom behavior, reading, and math. And that tries to take into account your brain and environment as well. And especially in the longitudinal study, where we want to follow from 1st grade onwards, we want to map the developmental profiles, and we want to figure out what's the impact of risk factors when they are modified by the severity or their accumulation. For example, comorbidities, when certain risk factors cluster together or accumulate, and their interactive effects. And then we try to look this for various motivational, socio-emotional, and environmental factors, and ultimately to the mental well-being. So one way to look at this is, bear with me with this graph, but here I want to illustrate that if we have problems in these domains, they might be overlapping: reading, math, attention, executive function, emotion regulation, and language and speed. And same children might have only some of these, or two of these, or three of these, or more. So what is affecting these? What are the cognitive domains? So we have given you in some of the studies some glimpse that there are specific cognitions, for example, speech perception or phonology, RAN or number sense, calculus, vocabulary. But then we have so-called more general, domain general factors or skills, like cognitive capacity, executive functions here, what I also told about, or language or attention span, working memory or inhibition. But then we have also this important realm that is emotional capacity, for example, reactivity, self-regulation, self-beliefs could be here, or self-concepts. And now we want to see that how are these related to these, for example, different problem areas or difficulties. And these arrows are purely hypothetical here. I have imagined them. And you can see that from the cognitive capacity, they could be related to almost all of them. And so also emotional capacity to many of them. And then, as seen already many times, we want to look how they are related to the environment and how the brain. And we know that there are genetic factors at the background, but we are not following molecular genetics in our study. I know that there's in Italy you have good groups doing this. I saw already one of my colleagues in the audience doing this. Yeah, so, and then we know that these problems actually also affect each other. So there's interactions. You can see that the big picture is rather complex, and we can maybe only isolate bits and pieces from here, but then with maybe more advanced analysis techniques to look at their relationships as well. Okay, so what we would want to do in our study, if we look at the risk factors or risk markers for reading, math, attention, and controls without any risk, and then we can follow them and see that there are certain also cognitive, neural, social, or environmental resilience factors, how they will lead to the third grade, fourth grade, and so on. But then we also have the similar factors that increase probability to get your learning difficulty or to have also socio-emotional problems. And then these may be your risk to lead to the dropout tract, like low self-esteem, low self-efficacy, dropout behavior problems, low mood, anxiety symptoms, and so on. So trying to figure these out is our goal here. And I know that for the ready, there is something a little bit at least overlapping with our goals as well. And I kind of like this picture myself. So we know that there are certain genes that will affect how our brain develops, how our networks develop, and this will be seeing then in the cognitive level, like speech perception, attention, working memory, and also actually now socio-emotional kind of issues at this level. And then they will lead into different profiles like language-related problems or attentional and dysfluent problems. And here we can have then also mental health and well-being problems depending on these complex interactions. And this figure on the right wants to illustrate that it may your severity of your problems may differ whether you have several problems or one big problem, or how are they kind of co-occurring together. Okay, our mission is inclusive and equitable education for all, improving well-being and mental health for children and young people, and enabling children to fully participate in society and reach their full potential. And we want to have societal impact as well, develop knowledge base, and knowledge can be applied to curricula with various professionals. And we want to have some direct contact with stakeholders as well. And finally, there is a story in Isopos or something like that. I don't remember the name. Isopos, yeah. And you probably remember this story. There was a rabbit that started, and then the turtle or tortoise. And what happened at the end, that the rabbit kind of took a nap, and the tortoise passed him, and tortoise, of course, reached at the end the first the end line. And the kind of what is the lesson of this is being the first to leave does not guarantee reaching the destination. And these, I think, are our slow readers, those who are fluent in math and maybe have some other problems. But we know, here I wanted to bring this picture for you. Noah Lyles was Olympic winner and bronze medalist from Paris Olympics 2024. And he posted on X that he has asthma, allergies, dyslexia, ADD, anxiety, and depression. And yet, despite these problems, he became Olympic winner. So there's a hope for everybody. And my very final thing is a postscript that I want to say always. What is normality or deviation from it? It's not good or bad. It's just different type of variation. You can be small or you can be tall. Most people are in between. But all of this is normal variation in mankind. And from the neurocognitive and genetic point of view, individual differences in our processes, such as auditory processing related to reading, they are part of typical variation in mankind. There are different profiles like this existing. And reading, instead of music and fine-tuned motor skills, happen to be important in society. If music was equally important requirement for the job market, we would need to start large-scale intervention program for the deaf musicians. Okay, thank you very much. These are my colleagues who have been participating in producing all the data. And thank you for your attention for this lecture.